Right. Welcome back again to our session. Our next speaker is Gabriel Noury. Sorry, I want to say your middle name because I don't want to butcher it. Gabriel is a product manager at Canonical. He has a PhD in robotics. He is very passionate about health, providing robotic solutions in health. He has a lot of siblings, but he loves Felipe, his last born, their last born. Funny enough, I was trying to get familiar with my speakers and I stalked them, but I found nothing but robotics on all his social media platforms, so I had to have some socializing with him. He is going to speak to us about open source in robotics. So take the floor and help me welcome him, please, everyone.
Thank you, Jessica. I really appreciate that intro. Just building on that point, when you come from a big family, a lot of the passion of certain technologies develop thanks to the involvement with them, thanks to the involvement with your brothers and so on. So yeah, I really appreciate coming from a big family. Welcome all. Today we're going to be talking about open source and robotics in this chat. This is more to celebrate your activity. As a community today you have been already contributing, and I'm going to show you how you are key to that success in robotics. I also want to say hi to everybody that is following us live. And one of the things that I'm not going to say but I enjoy during COVID time was the fact that when you were invited to give a presentation, you were talking to a screen. So you didn't have to worry about, I'm talking with 100 people or 500 people. No, it was okay. You were talking to a screen. The social pressure was taken out of the equation. It was just me and my laptop. And while this concept might be trivial or even vague for some of you, it plays a fundamental role in what is human-robot interactions. Just like my laptop, it is easier for people to talk with robots. Several studies have shown us that we feel more comfortable talking with them, sharing how we feel, sharing our struggles, our fears, our dreams. We feel safer, just like when you give a presentation to your laptop. But robots can do much more than what a PC can do. Robots have unlocked in healthcare new models for treatment, improving patient care, improving the response time, giving up more time to the healthcare professionals. I really like talking about this company. The name is Lika. It's a French startup that 5 years ago started a journey of helping children with autism. So the idea is that for children with autism, it's difficult to read the facial expressions of people, if they're happy, if they're angry or not. Robots can help you train them, can help them learn about these things. But robots can do much more than just that. They can also be helping us right now in agriculture, making things more sustainable, reducing waste. They are also helping us today delivering medicines in difficult regions, in cities where getting there by car is almost impossible. And they also help us cooking. And all of these examples are real. The last one, if you were wondering, is called Motley Robotics, and it will help you cook better food. And at the same time, the technology keeps evolving. Today, we see quadruped robots that are capable of standing in 2 legs and walk. Modular architectures that can shift an assembly to help them conduct certain activities. We also find small micro robots capable of navigating through our blood veins, and also some robots that play football, because why not? And here is what I was telling you at the beginning. One of the reasons that we have all of this is because of you. If you ever contributed to Ubuntu by advocacy or a technical contribution, give yourself a pat in the back, because a lot of these things were achieved thanks to you, to your contributions, and thanks to all the work that we're doing here together. Today we will explore how open source became the de facto for robotics development, how they build that community, how you can learn what they did so you can apply to your project, and again, how you're already part of it. So, a little of history. Back in those days, we go back to the 70s, to the 80s. For a long time, you will get your hands on a robot, and the first thing that you needed to do was to write a lot of what we called infrastructure software. You needed to spend months building complex robotic software infrastructure, basically drivers to the sensors and actuators, as you can see, and communication between different programs inside the same robot. And that was just to make the robot basically work, to do the basic things. We were building these machines with the only concern on the hardware and the low-level embedded software that drives it. For example, you develop your single Python script for controlling the motors, reading from the line detectors, reading from the ultrasonic sensors. All of that takes time. You did it from scratch, despite using the same sensors as others. Then what if you throw a wireless controller into that mix? As you can see, all of that script quickly gets more complicated. And if you wanted to, for instance, benchmark a different sensor, you needed to rewrite the whole thing. So we were pursuing these monolithic architectures and reinventing the wheel along the way. Another of the challenges that we were having is that we didn't have any of these key robotic applications. So if I wanted, for instance, my robot to move around, to do some navigation, I needed to develop that algorithm from scratch. If I wanted my robot to do some manipulation, I have to develop the algorithm for perception, for object manipulation, all from scratch. We didn't have any tools for visualization of data, for debugging, or even for simulation. All of this was either proprietary and for a specific robot with a specific set of sensors. Just think about that. 12 years ago, we didn't have any of these widely available. But despite that, today, we have all of those robotics examples that I show you, and that is crazy. And only then, after you build your infrastructure, after you build your tooling, you could actually do some robotics research, do an experiment, solve a problem, test and hypothesis. Too little time was dedicated to actually building intelligent robotics programs. That picture is from a really famous slide made by Eric and Keenan back in the early 2000s. It's not mine. They were robotics researchers at Stanford that decided to stop this madness. Back in the, sorry. Can we play the video? No. Okay, so they decided to stop this. And in 2006, they started a program called Stanford Personal Robotics Program. And this was a milestone for what we have today. Their aim was to build a framework that allowed processes to communicate between each other, plus some tools to help create code on top of that. A first step towards a middleware. And they implemented that in that robot that you can see there, called PR1, Personal Robot 1. The framework will eventually be called ROS, Robot Operating System. Despite the name, ROS is not an operating system. ROS is a middleware. It's a set of tools and libraries that allow us to have low-level device control, hardware abstraction, and communication with processes. So, ROS allow developers to adopt this modular architecture, sharing, reusing code, and reducing infrastructure development time. So our monolithic application, now it could look like this. In essence, what ROS is doing is introducing a standard message for certain kinds of data through what we call ROS core packages. Each node that you see in the picture sends and receives data messages over a topic, distance, velocity, and so on. Therefore, now my sensor or actuator could be used in any other robot as long as it provides the same standard message structure. So for example, if you wanted to switch your LiDAR sensor and rewrite, for instance, the distance sensor, the distance module, you could do that without having to touch any of the other components. It no longer matters if your distance sensor was connected by serial, Ethernet, or USB. If the ROS package was available for that specific sensor, it can interact with your whole structure. Everything was getting more standardized. In the same way, they start adding those tools that we were mentioning about visualization, for debugging, recording data, orchestration of services, and more. And a key milestone was achieved in 2010 with the integration of Gazebo, a simulation tool that was not even part of the ROS project in those days. It was part of the player stage project. In a way, it was a competitor to ROS back in the 2005, around those years. But they decided to take this Gazebo dissimulation tool that was having success in that ecosystem and bring it to ROS. So after 4 years of hard work, in 2010, they released the first general distribution of ROS, Box Turtle, on top of Ubuntu Hardy. So like many other open source projects, they pick up Ubuntu due to all the benefits that you love and you enjoy every single day. And since that first release, our synergy started. It's running? Yes, it's running. For the past decade, ROS has been natively supported in Ubuntu. So let me give you a little bit of context of that, of what we do. Every single LTS release of Ubuntu comes with a ROS LTS release, which means that every single time that there's going to be a new ROS LTS, we work with Open Robotics to be sure that there's all the ROS packages needed on Ubuntu before deploying that. Open Robotics is the maintainer of ROS. And today, Jellyfish and Hawksbill Turtle are working together with the release of Ubuntu 22.4 and ROS 2 Humble Hawksbill. But we are jumping ahead of time. First, ROS needed to face several challenges as they start building a community. Just like you, just like me when I had my own project, there's no community that is backing you up. Therefore, you have to start building the community, and that's where they were facing. Putting up a community is a hard work. If you don't believe me, you can ask our wonderful support team and all the time that they have spent putting and setting up this wonderful stage, this wonderful event. So during that time, many other frameworks were also available. URVI, Player Stage, Microsoft Robotics Developer Studio, which is that one. That's how it looked. They were trying to build their ROS. But none of these were a success. One of the main reasons was because they failed to build a community. Some of them went through the path of licensing. Some of them went through the path of you have to pay for this service. Making it open source was the first right decision of ROS. Another key decision was taken with the release of the Personal Robot 2. It's already on screen? Yes. And this was a robot that became a test bed for the framework. So Keenan and Eric, now working with Scott Hassan, investor and founder of Willow Garage, decided to build 10 of these robots and provide them to universities. So students, researchers can start using that framework that they created. The price of that robot was $400,000, 400K. So you can imagine yourself driving a startup, pushing those costs, trying to push a new framework that no one has used it before. They were under a lot of pressure to make that work. It's incredible. So now under this umbrella of Willow Garage, ROS started running different initiatives to help more robotics researchers get into the ROS framework. And to do that, one of the best initiatives that they took was their internship program. So between 2007 and 2013, 140 students, 140 interns came through Willow Garage. These interns, they became the spread vector of the ROS pandemic. And they also provided a lot of libraries that were desperately needed by the robotics community around the world, now with an open source license. Today, as some of you will know, we have thousands of ROS packages to help you reduce development time. What it used to take us 1 year of work and a fully fledged robotics team, today can be easily done in 3 months and 1 engineer time to develop a prototype, a simple prototype. And that is thanks to these community contributions. For instance, TF2, a transform library for robotics, lets user keep track of multiple coordinate frameworks. So you have a robotic arm, you have different joints. If I move in this joint 30 degrees, this joint 60, and this other joint 90, where is going to be my end effector? All of this is complex math, but it was hard work that you needed to always do as you change from different robots. Now there's different mathematical libraries that are available for you to use. The same with the Unified Robot Description Format, URDF, that allows you to create an XML file that describes the joints and links of your robot. So now you can take that and describe how your robot should be represented in a simulation environment. That has been standardized now. So you don't have a problem taking the robot that was developed in, let's say, Colombia, and combine that with your development environment that you have in Germany. And all the messages, standardization interfaces for sensor, geometry, and graph. ROS, this framework made it possible to reuse all of that. And again, this started running 10 years ago. So what we have achieved is an incremental growth in the number of ROS users, where a lot of effort was put into also documentation, improving the documentation, following stable releases processes, add channels for people to ask questions, or even organize community events like the ones that we're doing today, allowing people not only here, but also live to join us. And the community start growing because of that. They saw the work and they start joining the ROS community. And the same should apply to your projects, the same should apply to your startups, the same should apply to every initiative that you're trying to build. You have to do the extra work for others to take your project and push it as well as you are. So, ROS right now is everywhere. This slide is from Open Robotics, and it's describing what you find right now in the autonomous mobile robot sector. So these are robots that are widely used on warehouses. That is the main market for ROS, and one of the main markets for robotics besides industrial robotic arms. So we're talking about warehouse, for instance, in Amazon, moving different boxes, moving equipment and resources from point A to point B autonomously. And what you see here is the acquisition of some of these companies. So let's take the one on the top right, Fetch. Fetch was a ROS startup that started more than 6, 7 years ago, a long time ago, with one of the ROS, the CEO of the company was one of the people working in Willow Garage. And they were able to sell Fetch Robotics to Zebra for that amount of money. Amazon have acquired Canvas, the one that we don't know for how much, and so on. So you start seeing that today we're in that stage where all the exceptional unicorns that we have for ROS startups are being acquired by big international companies. The same analogy will apply to robots that are delivering goods and services. Some interesting companies, KiwiBots, Prime, Robotics, that is going through that journey as well of deploying their own robots in that sector. Yes, we might not see some of them in our daily lives. In some areas in the US where the regulation allows, we can see them more often. But nevertheless, this is another market that in the next 5 to 10 years is going to boom, especially because at the end of the day, it's taking the technology from warehouses and applying that technology to hospitality, to healthcare, to offices, to delivering normal day goods. Another sector that is well developed is agriculture. Big companies such as John Deere has been doing a lot of acquisitions of ROS startups, and that is just going to continue. With the development of this sector, like we were saying at the beginning, we're going to a path of more sustainable farming, more sustainable delivery of food to the world in order to reduce waste. So a lot of work that is being done in autonomous tractors is being right now trying to be pushed into that industry. Something that you have to remember is that in these sectors, there's no the same strict safety regulation that you have to provide with autonomous vehicles. These are controlled environments, therefore it's much easier to have an autonomous tractor without someone driving that, okay? And of course, we go to autonomous vehicles. If you've been following robotics for a long time, you know that in 2008, one of the first DARPA projects is the first time that ROS was used in one of DARPA missions. And since then, the companies that we have seen, companies that have made spin-outs of Google and so on, are ROS users. And Apex AI, the one on the top right, is another framework for you to develop these autonomous mobile applications based on ROS. Apex AI is one of the first organizations that I know that was able to go through a certification process of the ISO, if I'm not wrong, 26262, and certifies ROS modules, certifies an open source project. They did that after a lot of work, 3 years of work, going line by line and being sure that those modules were written according to the specification of the certification, which is a lot of work, so a big congratulations to Apex AI for doing that. And Autoware, another project that builds on top of ROS, open source, that allows you to get access to simulation tools, to get access to autonomous navigation algorithms, and other tools for you to deploy autonomous vehicles. So, today is expected that in 2024, we will have around 13.5 million of robots running ROS. And that is a huge number. And with ROS, we also expect to have Ubuntu deployment increase. These are some of the interested robots that I wanted to share to you today that are running Ubuntu and are running ROS. And so, like we were saying, autonomous mobile robots for warehouses, roughly 90% of those are running Ubuntu and are running ROS. And the same in autonomous mobile vehicles. I don't know if you have noticed that project of Indy cars, autonomous driven cars that are going at incredible speeds, competing between each other as well, so they overtake each other without a pilot there. It's amazing that we are able to do that now today. In the middle, you see everything that is cobots. That is the new robots that we will have in the industrial sector that will allow you to have a robot in a working space. So no longer we will need to have cages around a robot. We can have people working closely together with the robotic arm. We have also our quadruped robots helping and reaching more industries. That one is also running Ubuntu and ROS. And we also find NASA deploying robots to space to help astronauts, that one there, face isolation in space. So when they don't have people to talk with in space, they can talk to the robot in the same way that I was talking to my screen when we were in the pandemic giving presentations. So our responsibility and commitment to this community will keep growing. This is what we are bringing today to the robotics ecosystem. A whole infrastructure for them to fill the next gap. The next gap that is software deployment. Robotics companies today, they find themselves in a tricky situation where they have to deploy, where they have to maintain software. They find themselves doing the job of many ISVs. And therefore, they are spending resources, they are hiring people to take care of that. But doing that doesn't help you build better robots, doesn't help you improve your hardware, doesn't help you improve features, just takes time from you and takes money out of you as well. On the other hand, Canonical has been doing this for a long time. We deploy Ubuntu to millions of users, we make that available, and we update that every single time. So what we want to do for the robotics community is provide you with the same infrastructure. So you love developing with Ubuntu, then you can deploy it with the snaps and on top of Ubuntu Core. So probably you have heard snaps a lot inside the context of desktop. In my opinion, snaps, they shine the most in embedded applications because they allow you to do all of this without you having to set up new infrastructure. If you want to standardize different channels as beta, experimental, stable for your customers, you already have that. If your robot is being updated on the field and for some reason someone plugs off the robot, there's no longer power, the robot, when it boots again, is not going to be broken. It's going to jump to the previous version of that application. You have Delta updates, so when you have software, when you have a robot that is really far away with a poor internet connection, thanks to the Delta updates, is only going to install those binaries that change between the previous and the current version. Setting up all of that infrastructure is the equivalent of reinventing the wheel. It's the equivalent of making those mistakes that we were doing in the 80s, in the 90s, where we didn't have that open source community around robotics. And as we saw that many people were deploying Ubuntu Desktop and Ubuntu Server with their robots, we decided to create something better for them. Ubuntu Desktop, Ubuntu Server is in the name. Desktop is for desktop, server is for servers. Ubuntu Core is something that we created for embedded devices, for IoT devices, for robotics. And the great benefit is that at the back of it, it comes with all this set of features that you don't have to, again, integrate, that you don't have to maintain. Things as secure boot, full disk encryption, the minimal image as well. Ubuntu Core is in size reduced image compared to Ubuntu Desktop and even to Ubuntu Server because you only have the bits that you actually need. So for instance, if you are using the Raspberry Pi, you don't have to install the full Ubuntu Desktop image that contains some things that you actually don't need to deploy your devices. Ubuntu Core comes with essential things for you to run your applications that are running as snaps. Plus the 10 years of security commitment. Developing a robot takes more than 3 years to come up with a minimal viable prototype, and then to go to market, let's say 4 years. So after 4 years, you are just close to 1 year of being end of life, because that is the time of a LTS release of Ubuntu. That is the time of the LTSs of ROS as well. Working with Ubuntu Core, you get 10 years of security maintenance. So that device that you're putting on the field, you can tell your user that the OS, the kernel, the base layer, is going to be maintained by 10 years. Okay. And I see that I went too fast with the time, but well, that's how it is. I want to finish with this question. Where to start? I got this question during an interview in Roscon. If you are new here to robotics and you want to start in this field, but you think that you need to study robotics or mechanics or electronics or have a PhD in robotics, that is not true. Like I was saying at the beginning, you are already contributing if you're contributing to Ubuntu. And the field of robotics is so big, that it touches so many different fields. That robot there, probably you have seen the videos, right? That robot there is running Ubuntu. And for developing that robot and for making that robot successful, of course you need people that know mechanics, of course you need people that knows electronics, but you also need people that knows about psychology in order for them to develop a robot that will actually have a meaningful interaction with the people. You also need people that know about marketing, because at the end of the day, the robot is going to say things. And if it doesn't say the correct things, the people are not going to adopt it. You also need to develop robots that look appealing, so you need design skills. The only thing that you need to become a roboticist is the passion. That's it. If you have any questions about anything, please, now is the right moment to ask them.
So much, Gabriel. Okay, what an interesting talk. We have a question here.
Hey, thank you for your presentation. If we want to run Humble on Mi Pepper, which is better, Ubuntu Core or Ubuntu 22 version? Thank you.
I'm not sure if I understood correctly the question. If it was about a specific robot and running Ubuntu Core on that robot? Can you repeat the question one more time, please? Sorry.
We want to run Humble version on our Mini Pepper robot.
Okay.
So which Ubuntu version is you recommend? Ubuntu Core or Ubuntu 22?
Perfect.
Thank you.
Okay, that is a question more about Ubuntu Core. So, yeah, Ubuntu Core is this OS for deployment of embedded devices, IoT devices, and so on. The question is simple. If your robot is going to become a development platform, let's say I want people to hack into the robot. I want people to be able to break things around. I want them to be able to see the source codes of all my applications and so on. I want them to, be able to do anything they want to. Ubuntu Core is not for you. Then, of course, use Ubuntu Desktop, use Ubuntu Server. If, on the other hand, you are deploying a final application that you don't want your user to hack into. For instance, I don't want to deploy my warehouse robot and allow my user that, I don't know, by mistake, change something in the configuration, change something in my code, and by mistake, injure someone with one of my robots. I don't want that. Therefore, yes, I go with Snaps and Core. So think about that, and that's also a big difference of why we use Snaps. Snaps are for deploying final applications. Snaps are not for deploying code that you want someone to debug. Okay? Cool.
Thanks for the mind-blowing presentation. It was really great. Being ROS a kind of a standard, I'm pretty sure we're able to run that on other Linux platforms, but Ubuntu. In such case, what's the percentage of the market share you'd say we have nowadays, if it's possible to estimate?
I'm so sorry. Those mics are so difficult to understand what people are saying. Can you repeat one more time?
Yeah, I wonder about the market share of Ubuntu in the ROS ecosystem, because being a standard, I bet it's possible to run on other Linux platforms.
Cool. Good question. So, like I was showing you I'm returning to, sorry for the people that are following live. The question was about market share, market use, user use of Ubuntu inside the ROS ecosystem. So one of the slides that I show you, let me go back in time. That one. Perfect. Those has been most of the ROS releases until 2019. When they started the project, they started working with Ubuntu, and therefore they were testing on Ubuntu, and they were deploying those packages to be working right away on Ubuntu. And since then, they continue that trend. And like I was telling you, every release, we work together to be sure that ROS is going to be working even before they deploy ROS, they release ROS. So, as you can see, that also makes us kind of the preferred OS for running ROS. Every single time that there's a bug, they are testing it first on us. And they also have that ability to talk to us, to our engineer team, and say, hey, we have this issue, please can you fix it? And we try our best to be good with them and work as fast as possible because of the huge community. So yes, you are right. You can install ROS in more OSs, but we do all the work to keep people happy on Ubuntu. And that's why people stay and work with ROS in Ubuntu, and we hope that that is going to keep being the de facto for the industry.
Hey, I would like to ask a question. I'm thinking about maybe deploying my software as a manifest. So that means that I have a direct correlation between my backend server, my backend version, and my robot version. And in case I fail to deploy my app onto the robots, I'd like to have an option either for a rollback and maybe even notify the backend server that this is what I want to do and revert also the backend server, the backend version. So, sorry.
I'm so sorry, but it's super difficult to hear people. If you don't mind coming closer, because at the end of the day, you can, and you can ask me again the question, it will be easy for me to hear you. Thank you.
Well, the warehouse is a very, I would say, problematic environment in terms of I cannot update half of my robots, and I need to make sure that full maintainability with the backend version. And they are completely different things because I cannot ensure that everything was deployed correctly. How can I create manifests for making sure that I'm having a good rollback options, I'm completely synchronized with the versions, and if there's any problem, any error, the backend will know about it as well and also will block the update.
That's a good question. It's a question about the nature of the challenges that robotics companies have to face on that specific sector that is warehouses, and it's true. Think about you have a fleet of robots. You have more than 100 robots, each one running different applications. Some of them are not even from the same company, let's say. But let's talk about the ones that are yours and is your software with different optimizations tailored for different applications accordingly, okay? So yes, that is an issue, and it's an issue that many robotic companies face, not only on warehouses, but in general. The first step is your architecture. The moment that you design how are you going to make your models, how is going to be break down your application, is the first thing that you have to consider. And unfortunately, today, due to the dynamics of the startup life, due to the dynamics of the market, companies don't think about that enough. They just try to build a first prototype that works. And once that works, they take that prototype as their MVP and they deploy it. And then they see that the modular architecture that they took, if any, is not modular anymore. Okay. According to your application, according to the different features of your robots, you will have more or less different parts, okay? I cannot tell you which parts you have to create. That is up to you and your type of architecture. But some of the things that Snaps allows you to do is to break down your application into different modules, okay? So, for example, let's say that you are working with 2 ROS, 2 Humble applications. You can break that down into a core package of ROS applications. So that is all everything that is ROS core and so on. And that could be your one stable module that is feeding information to your application A and your application B. Okay? Now then, you will see that depending on what you want to update, it will be only A, it will be only V, it will be AV, and also this core fundamental module that you created. And that is the process that you have to do at the beginning when you're doing that architecture. How I'm going to break down my application? How many different modules in order for me to be easy to update these things? And yes, it's a difficult problem that each company have to address. But just to give you an example of how bad things are today, some of the biggest manufacturers of robotic arms, they don't update anything in the robot for more than 20 years. They could have thousands of CVE, security patches that have not been applied, and they don't care because of that. They are afraid of doing what you just asked me, how I can update and orchestrate all that. It's an issue, for sure. It's not a reason not to make any updates on your robot, because that's a huge vulnerability that you're introducing to your customer. But it's a call to action for every single startup to think about how they're going to break down their architecture in order for them to have a plan for upgrading, okay? We just provide you with infrastructure. We cannot go to that level of which application and so on. But again, having that modularity is one of the benefits of using Snaps, okay? Hope that that was somehow useful. We can talk more about that later, and you can tell me more about your application. Any other questions? You can also ask questions about the Tesla robot and all those things.
Thank you, Gabriel. So Just asking, let's say we have thousands of robots sold already and use Ubuntu Core and plus Lab install the software. And then we want to upgrade them. So as a developer of this robot, where are we going to push our updated packages and how the robot get the new update? Thank you.
So, one of the things that is running on Ubuntu Core is Systemd. Systemd will allow you to run Snapcraft. Snapcraft will allow you to update things on the robot. So you were part of the workshop of Snaps. If you're interested in learning more about this, and I'm talking to the people live there, you can go and visit Robotics Snaps documentation, and you will find documentation, and you will do basically the same workshop that you were part of. So at the end of the day, we were talking about the store, right? Let's go to this picture. There we go. Perfect. So as you can see, there's two big ways that you can make your Snap available to your devices. One of them that we make available to everybody here is for us to host your Snap in the Snap Store. Okay? So let's say that you want your Snap to be widely available to anyone. It's going to be living there. Okay? Users can then can install and update accordingly to their needs. Okay? Now, let's say that you have your line of devices and you want to have that granularity. I want to update all of my fleet A. I want to update later fleet B with a Snap 2.3. I want to update fleet C with Snaps A, B, and C. To have that level of granularity, we provide a service to companies that is our private brand store. With that, it's a paid service. I'm saying that up front. You will be able to have that level of granularity and have that software fleet management architecture that you can utilize. If you don't want to use that and you want to develop your own, you can do that. At the end of the day, as you saw on the workshop, you are creating a file .snap that you can choose how to use, you can choose how to deploy for your users and so on. Okay? Cool. No more questions?
Any more questions? Okay. That means we are done for now. Thank you so much, Gabriel.
Thank you.